Hello everyone, hope everyone is doing well. Today we're going to talk about discrete distributions. We are going to look at how to calculate the mean and standard deviation of a discrete distribution, and we're going to look at two different examples of discrete distribution. So we're going to look at the mean, variance, and standard deviation of discrete distribution of an example. And then we're going to look at two different types of distributions, as I said. So binomial distribution and Poisson distribution. So first, let's talk about what is a discrete distribution. A discrete distribution, in very simple terms, it's basically a distribution that is countable. So that means the number of outcomes can be counted. So if I look at a dice, and a dice has 6 sides, so the outcomes are going to be 1, 2, 3, 4, 5, and 6. So if I roll the dice, it's going to be one of these 6 numbers. And the probability, if it's a fair dice, it's always going to be 1/6. So it's going to be 1/6. It will be 1/6. So if it's always going to be 1/6, that means that the probability of getting a 4 is going to be 0.16. The probability of getting a 2 is 0.16. Now, there can be cases where it may be a little different. So let's say we may have, if we are counting number of days of rain in a week, so we may have, in a week, we may have 0 days of rain, 1, 2, 3, 4, 5, 6, 7 days of rain. So we may have all those days of rain, and the probability of all those rain could be, so let's say these are my probabilities of the occurrence of rain. So the probability of having 0 days of rain is 30%. Probability of having 6 days of rain in a week is 5%. Now, if you notice, if I add them up, I will get that the probability, they all should equal to 1. So that is one good thing to check before we start our calculation. Now from here we can calculate what is the average number of days of rain that we can have. Usually what we did in our case, let's say whenever we did discrete distributions, if I wanted to find mean, mean would be basically 1 over n, and sum of, we go from I equal 1 to n, xi. So n means number of observations, so if n equals 5, then this basically means I would go, there's 5 numbers, x1 plus x2 plus x3 plus x4 plus x5 divided by the number of observations is 5, so it's 5. Now if I had 5 numbers, if each of the x's denoted a different number, so let's say my number is 5, 10, 15, 20, and 25, then I would have just done 5 plus 10 plus 15 plus 20 plus 25 divided by 5. Now, if I kind of spread this denominator around, I could write it as 5 times 1 over 5 plus 10 times 1 over 5 plus 20 times 1 over 5 plus 25 times 1 over 5. So if you look at this, it kind of looks like, each of the numbers has some kind of a weight with it. So we could see that it is basically the number xi times the probability that xi is showing up. So this is the number. Now what we're doing usually for finding means is that we treat all these probabilities to be equal. So all these numbers that we have in our list, they all get the same weight. However, in our case now, whenever we have a discrete distribution, the weights are different. So what we would do something very similar. Each of these numbers are xi, so we would find xi times the probability that x equals xi. And so what I would do is just multiply the numbers and the probability. So I would say this would be my number, and then I would do that for all of them. So I'm going to just copy the formula all the way down to here, and then I would just sum it. So the number is 1.79. So that means I would say the mean of days. So I would say the mean value of days of rain per week is 1.79. So just to recap, what we would do here is we're taking each of the numbers and multiplying it with their corresponding probabilities. And so we get this column. And then what we do is we add all the values in this column to get our mean value. It is also called expected value and written as E of x. So it can be written in both ways. Now, if this is my mean, how do I find the variance? If you remember from our variance formula from before, it's going to be 1 over n minus 1 if it's a sample. I sum from I equal 1 to n xi minus the mean of x of all those numbers, and I square it. So this is my variance. And if you notice again, if we distribute it out again, so let's say my number is, let's take just 3 numbers. So we have 2, 3, and 4. So then my mean is going to be 3. So if I write this out, and my x bar is also, or my n is also 3. So it is going to be 1 over 3 minus 1, which is equal to 2, 1 over 2. So that's going to be my weight here. So it will actually look like 1 over 2 times 2 minus 3 square, where this 3 is the mean from here, plus half 3 minus 3 square plus half 4 minus 3 square. So in that case, as you can see, we're doing the same thing here. We are spreading out the numbers. We have our weights in front. And why do we, and just to recap, why are we subtracting 1 from our number of observations? This is because of degrees of freedom, and we're going to cover it in a later lecture. But here we're doing the same thing. Think about this as weight or probability, and this is our deviation squared from each of our observations. Each of our observation or our sample is different or deviant from the mean. So this is what we will be doing in the case of variance and standard deviation. So what we will do first is we will do xi minus the expected value of x. So my xi is that minus the expected value of x, which is this value. So I want the numbers to, or at least the average value to remain constant throughout. So I'm going to put dollar signs in front of the p and in front of the 20. And this tells Excel that not to move this cell box as I copy the formula below. So I'm going to copy all this formula all the way down here, and then I will square it. So I will do xi minus e of x squared. So it's just taking this number and squaring it. So that is going to be just that squared. After we square it, we have to multiply it with the probability, or the weight. So then I will just we can all do this in one step, but I'm doing this in step by step so that, it's easier for us to follow. So we will do probability of xi times that number, which is, here's my probability, times that number. So it's going to be this column, or this number, times this probability. And I do the same thing. I copy all the formula all the way down. And then finally, I'm going to add this column. And so this is going to be my variance. And so my standard deviation will be just the square root of variance. But first, let me copy this formula and put it on the side. And my standard deviation is going to be just square root of this number. So if given a discrete distribution like this is how we would calculate our mean and standard deviation. So we would say that the mean days of rains are on an average in a given week, we may have 1.79 days of rains with a variance of 3.26 and a standard deviation of 1.81. Now, we've just looked at how to find the mean and variance and standard deviation of a discrete distribution. So the first distribution that we will look at is the binomial distribution. This is a very simple distribution. And it has only two outcomes. So think about like a coin toss. So you can either get a head or a tail. And if it's a fair coin, basically you have a 50% chance of getting a head and 50% chance of getting a tail. Or it could be like a free throw. So if you're a basketball player and you're in line and you're about to make 2 free throws, so you can either make 0, 1, or 2 free throws, and then you have a percentage. So usually you have, like whenever a player is making a free throw, they're usually given a stat basically saying that free throw percentage is going to be, let's say, 76%. So this is based on their historical value. So like if the person scored 100 free throws previously, that person scored 76 of the free throws and missed 24 of the free throws. But now they're standing in line to score 2 more free throws. What is the probability they'll score 0 or 1 or 2 free throws? This is what binomial distribution helps us to find. There are also others, let's say, things like college acceptance. Let's say a college either accepts your application or rejects. Let's just say there's no waitlisting, and let's say the acceptance rate is 22% and the rejection rate is 78%. So then from here we can find out what is the probability of getting accepted. Like if I apply every year for the next 3 years because I really want to get into this college, what is the probability of getting accepted versus not getting accepted? So these are examples of binomial distribution. Now the formula for binomial distribution is a little complicated, so I'm not going to show it here. I'm just going to show how you can implement it in Excel. So let's talk about free throws. Let's say the player got fouled while making a 3-point shot. So if a player gets fouled at that point, they get 3 free throws. Now, if you are making free throws, you can either make 0 free throws, 1, 2, or 3 free throws. And let's say the field goal or the free throw percentage is 76%. So let's bring this here. And so what we have to find out, okay, this is, as we said, this number that we have, this is from the past. Now, what is it going to be right now? So it could be, what this means that the player could miss all 3 free throws. So 0 means all 3 free throws were missed. And then 1 means one of the 3 free throws were made. And then 2 of 3 free throws were made. And finally, 3 of 3 free throws were made. Now, in these 2 cases, in 1 of 3 free throws were made and 2 of 3 free throws were made, we don't care. The order does not matter. Which means that, you could make, let's say if I'm making 3 free throws, I could make 1, 0, 0, or 0, 1, 0, or 0, 0, 1. It doesn't matter which order I scored it, these three occurrences are treated the same. Now, how do I find the probability for that? So in this case, I'm going to use the Excel's formula. So it's going to be equal to, actually let me move these because I will need them later, and I'll make this bigger so we can see what's happening. Let's call this event. So the probability, the formula we are going to use is called binom.dist. So it's binom.dist. And then I open the parentheses, and then the first thing it's saying, the number of success. So number of S is number of success. If you scroll down here, it will tell you, if I click on it, it should tell me what it is. So this is the number of success. So in this case, I'm saying there's 0 free throws made. Next is trials. How many times did I try? So I tried 3 times. The probability of success, well, it is 0.76. So let us just write 0.76. And cumulative, let's say, for now, we will say false. And we are going to see what true is in a bit. But for now, let's just write false. And this is my probability. So it's telling me that if I am a 76% free throw shooter, the probability that I miss all 3 free throws is going to be around 1.4%. Now, if I want to find the next ones, so let me just copy the formula down here. So if I do this same thing again for the next one, I move it down, and you will notice that if I look at this formula, it's saying that what is the probability that you're making 1 free throws out of the 3 trials, and the probability is 0.76 of success. And if I copy all these things down, I get these numbers. Now, if you look at it, if I sum the probabilities, it will equal to 1. So if given that you're in the past, your field goal percentages was 76%, or sorry, not field goal, your free throw percentages, this means that you have scored 76% of your free throws in the past, and that does not mean you're going to score 76% at this moment for every single free throw. So that means that from here, you have a 1.38% chance of scoring 0 out of 3 free throws. And then we can write the same thing for the others. So I can write all those things, but I can also write, you have 43.89 of scoring 3 out of 3 free throws. So this number, our past performance, helps us to understand what we will be doing in the near future. We can do the same thing with coin toss. Let's say if I toss the coin 10 times, what is the probability I get 7 tails and 3 heads? Or what is the probability I get 4 tails and 6 heads? We can calculate that. But here, before I try that, here we are looking at what we said is false. What about if I wrote true? So if I did the probability, and if I did the same thing, I wrote equal binom.dist. The number of success is 0, and number of trials is 3. And the probability of success is 0.76, and then I write true. In that case, the first number is exactly the same. What if I copy them down? If I copy them down, you will notice that the numbers keep on going up until it reaches 1. And what true does is that it adds up. So this is the cumulative distribution. So instead of writing probability, we should write cumulative probability. What this means is that if you add these two numbers, so if I add the first 2 numbers, I will get this one. If I add the first 3 numbers, I should get that number. And if I add all the 4 numbers, I should get 1. So it is just giving us a cumulative increase or the cumulative value of the probability. Now let's look at the coin toss. Let's say probability of getting a tail is 0.5 or 50%. So let's say no event is landing a tail, and if I'm doing it 10 times, so I can do 0. So the probability, even though probability of getting a tail is 50%, I could, in theory, get 0 tails, or I could get all 10 flips leading to a tail. So the probability would be, or let's just write probability, it would be equal to binom.dist. The number of successes is going to be the first number, 0, trials is 10, probability of success is 50%, and cumulative, let's just say, is false. And so the probability of all or getting no tails is very close to 0. And we can then copy it all the way down, and we get this probability. So if you notice that the probability of getting 5 tails is 25%, 6 tails is 20%, so we get a nice, the end tails are very low, and then as we move closer and closer to the middle, we get kind of a nice shape. So if I draw a table out of it, so if I do a bar graph, I need to change the bar graph. So if I look at the probability in the vertical axis and the outcomes in the horizontal axis, you will see that it gets a nice kind of a bell shape, of almost like a bell shape with some gaps in between, of course, because it's a discrete distribution. But as you can see that if I getting 0 or 10 tails is very low, the probability, but as we go closer and closer to the middle, the probability rises. Next, let's look at Poisson distribution. So Poisson distribution, Poisson distribution is kind of like a count data. So let's say we're counting something. The name Poisson means fish, and it helps us, it's basically thinking about like how many fish are caught in every hour or something like that. So Poisson distribution is used to understand flow of, let's say, customers. Supposing I have a customer service desk, and I need to know so maybe I need to know how many calls do I get per hour. So if I have this customer service desk to manage, it will tell me that, okay, so do I get, on an average, I may get, let's say for historically, my average is, looking at other days' calls, let's say from the past, the average is, let's say 3 calls per hour. So now, in this case, if I get 3 calls per hour, that's my historical average. But let's say the holiday seasons are coming and I may get more calls. So it could be that I may get, in the next hour, I may get 0 calls, 1, 2, 3, 4, 5, 6, 7, or even 8 calls per hour. And I may need to know the probability of that in order to know how many staff I need to hire. So for this, since it's a flow, because I'm looking at how many calls I may get in an hour, so this is where we use Poisson distribution. So again, Poisson's formula is easier, but I mean, Excel does it for you, so we're going to use that formula. So we're going to write Poisson.dist, and X is going to be how many calls we get, which is 0. The mean is 3. And cumulative, let's just say, is false for now. And so we have a 5%, almost 5% probability of getting no calls in the next hour. And if I copy all this down, I get all the different probabilities. So this is telling me then what is the probability that, let's say, there is a 16.8% chance that I may get 4 calls in the next hour. There's a 2.1% chance I may get 7 calls in the next hour. We can also use it for, let's say the average fish caught is 6 fish per hour in a lake. So let's say that there's a fishing competition and you want to know how many fish you can catch in an hour. And let's say the average is 6. So that is the average from the past. Now you're in the competition, so you want to look at how many fish can I catch? What is the probability of each catch? So I may catch 0 fish. 1, 2, 3, 4, 5, 6, 7, 8, 9. I may catch 9 or 10 fish. So again, we find the probability. And so it would be the same idea. It's Poisson.dist. The mean is going to be 0. Or sorry, the x value, that is, means what is the probability I'm going to catch 0 fish. The average is 6, and cumulative, I'll say, is false. And so there's a very small chance of catching just no fish in the next hour. And if I copy and paste all the formula down here, I can see then how many I can catch. So it seems like there's a 16% chance that I may catch 6 fish in an hour. There's a 9% chance I may, or there's a 7% chance almost, sorry, not 9, it should be 6.8% chance that I may catch 9 fish in an hour. If you notice, if I sum all these, it's not going to be quite equal to 1 because I could, in theory, keep on catching more fish. So if I go to 11 and 12, I will have some probabilities here. And so they'll keep on increasing. And so it never really goes quite to 0. It goes very close to 0, but we still have some probability of catching large quantities of fish. Okay, so this is how we use Poisson distribution and binomial distribution. One of the things we have to know is, okay, what is the mean and variance of the binomial distribution and Poisson distribution? So the mean of binomial distribution is just going to be n, the number of observations, times the probability of it happening. So if we were looking at the free throws, my n is 3, and my probability is 0.76. So it's going to be 3 times 0.76. So on an average, we should be making 2.28 free throws. Variance formula is going to be n times prob times 1 minus the probability. So which means it is going to be the same number here, but after 0.76, we have to write 1 minus 0.76. And there has to be a parenthesis here. So that number now, if I try to find the number, it is going to be 0.52. And standard deviation is going to be the square root of the variance. So it's going to be just of that number. So my variance or my standard deviation is going to be just the square root of variance. So finding the mean and variance and standard deviation of binomial distribution is pretty easy. It's even easier for a Poisson distribution. Here we see that in our number of calls per hour, the mean is 3, and the variance is also equal to 3, and the standard deviation is just going to be the square root of 3, which is going to be just 1.732. And the same thing here, if my number of fish caught is 6 per hour, if that's the mean, my variance is 6, and my standard deviation is going to be the square root of 6. So mean is 6, variance is 6, and standard deviation is going to be square root of 6. Hopefully this was beneficial, and I will see you at a later video. Have a good day.